Okay, I'm going to get started. Perhaps some other people will join us in a moment. I'm going to start by introducing myself. My name's Sarah Seleznyov. I've been working in schools in education for about 30 years now, and I got involved with Let's Think about 20 years ago when I went on a programme for myself. So I've been through the experience that hopefully you'll be joining me for. And I loved it so much, I did another course immediately afterwards, and it ended up becoming a Let's Think tutor. So for me, it really, really changed my practice. I really felt when I went through the program, it was a big shock because I thought I was a really good teacher before I started the program. And then I realized that I could be so much a better teacher once I'd been through the program and found out about these lessons. And it really, really changed the way I approach my teaching of mathematics. I now have my own school called School 360, which is in London, in England. And I've introduced Let's Think across the school. So I've trained all my teachers to use the approach, and they also love it. And they do that once a fortnight with the children in their classes. So it's made a real difference to my teaching and the way I help other teachers develop their practice. And I'm hoping it can do the same for you. It'd be really good to know who you are and what your role is in your school and where you're based, and also to know what kinds of challenges you experience with teaching mathematics in the classroom. So I don't know if you want to unmute yourselves and say that out loud, or if you want to put that into the chat. But yeah, let me know your name, your role in your school, where you're based in the world, and what your challenges are that you have in teaching mathematics in the classroom.
We can start. So I'm Alexandra. I live in south of France. I'm teaching in a medium school with very young pupils and older, and it's becoming more and more difficult to have children concentrated and to love to learn, except when we are in small groups. In small groups, it works very well, but not so well when there are a lot in the class.
A common challenge. Alex, I don't know if you want to introduce yourself also.
Yeah, I'm Alex Black, and I'm based in Zurich. I've lived there for 37 years. I used to teach in an international baccalaureate school. I was teaching mathematics and science in lower secondary all the way up to grade 10. In the last 8 years, I've been working as a consultant, working with teacher development programs. So I'm looking forward to hearing more about Let's Think.
So welcome, both of you. In this session, I'm going to give you a brief overview of the Let's Think approach and some of the evidence for it. And then I'm going to give you some ideas of how these strategies can be put into your everyday mathematics teaching practice. Because although these lessons are only taught once a fortnight, what I found when I went through the training was that it changed my pedagogy across the curriculum and in my everyday mathematics teaching. So I'm going to start by giving you, let me just share my screen, and excuse me, I'm a little bit croaky this evening. Let me just find the right screen. I'm going to start by giving you a little bit of the history of Let's Think and where it comes from. So can everybody see this screen?
Yep.
Yep. So this is a little bit about how long Let's Think has been around, actually. Its original name, its research name, was cognitive acceleration, which is a bit of a mouthful. So it's been renamed in recent years to be called Let's Think, which is a bit more practical. So it began in the 1980s, as you can see, and it originally began in science. It was cognitive acceleration in science education. And after that was shown to be very, very effective in terms of raising children's attainment, they began to experiment in maths. And then more recently, there's been some experiments in English and in other subjects of the curriculum. And just a little bit of graphs here to show you the difference that it makes to students' learning. So this graph shows what happened for 16-year-olds in the UK who was using the science intervention in their schools. the Let's Think Science intervention, and you'll see that it made a really, really big difference to their results. So you can see in the graph here that the case schools, the ones who were studying the program, were the ones with the little crosses on, and you can see they're way, way above the average schools, and all of the control schools are much, much lower down. So it made a big difference to their attainment after studying case for a couple of years. Sorry, let's go on to the next one. Yeah, and then you'll see also it didn't just make a difference in their science, in the subject where they were taught Let's Think, it also made a difference in their maths and their English GCSEs, the exams they studied age 16. And that was 3 years after they'd studied it in year 7 and year 8, so as 11 and 12 and 13-year-olds. So what we're seeing is that if you do these lessons once a fortnight over a period of 2 years, it makes a difference across the board in terms of curriculum understanding and development. And that lasts for a long time after the intervention. And that's certainly the case I found for my own pupils in my own school and in my own classes. So this is another very similar one in terms of maths, showing exactly the same thing. Again, 3 years after the schools had experienced Let's Think Maths. You'll see the red dots there are way above the line. They were doing way better than the blue squares, which are the control schools that didn't have Let's Think in their classrooms. And that was 3 years after the intervention. So what we're seeing here, and this I could have shown you many, many more graphs of many different times. What we're seeing here is a big impact on children's thinking and understanding across the curriculum that lasts over time. So that's a little bit about the proof that Let's Think works. But I'm going to go over some of the sort of tips that I think might help you and which we're going to look at as part of the course. So, and lots of them actually relate, particularly actually, Alexandra, to your problem about concentration beyond working in small groups, because that's something that we're very familiar with as practitioners of mathematics in the classroom. So the first tip that I'm going to give you is about making it real. All of the Let's Think lessons that we teach are set in a real life context. So they are real life problems that the children will care about solving, and that makes them interested to be engaged with the problem that they have to solve. They'll be solving it collaboratively, and by making it real and making it motivating, that makes them want to engage with it. Sometimes we don't even tell the students that this is a mathematics lesson. We tell them it's a thinking lesson. And what we're asking them to do is draw on the mathematics teaching that you've given them in your daily lessons and use it to solve problems that are disconnected from that teaching of that particular concept of mathematics. So I'm going to give you a couple of examples of this for different age groups. This one is one that can be done with 10-year-olds or above. And this lesson is called The Largest Rectangle. And the children are given a worksheet that looks like what the image you can see on the screen. And they are asked, which is the largest rectangle? Now, that's quite a complicated question because there's lots of different ways of measuring a rectangle. Are we measuring its length? Are we measuring its width? Are we measuring its perimeter? Are we measuring its area? And this leads the children down a little challenge to compare perimeters and areas. And as part of that process, to help them understand in practical terms what the length times width calculation for area actually means and where it comes from. We find at this age group, a lot of children know the length times width equals area calculation, but very few of them understand why. So I'm going to show you a couple of examples of children's work in this lesson. Here you can see, and we do this without rulers. So we ask them to use it using their own measures. So they will use fingers or anything like that. So their understanding of measure doesn't need to come in the way of them solving this problem. They have to work out by estimating which has the largest perimeter, which has the largest area. We see a lot of children at this age group who will measure every single side and add them all together. And only a few will realise that in order to calculate the perimeter, you don't need to measure every single side. You just need to measure 2. And you can see that happening here. This child only measuring 2 on this particular sheet. Here's another example. Again, you can see this person measuring the bottom left there. You can see them measuring every single side in order to check the perimeter. Yeah. And then we ask them to find the area. We give them squared paper to find the area, but some of them will deduce that they just need to multiply the length by the width and get the area. And when they do that, we ask them to explain how that calculation works to the rest of the class. So this is set in a real life kind of problem-solving context, using all the skills they will have learnt in their day-to-day lessons about measure. Here's another example for much younger children. So this is for children who are 4, 5, 6 years old. And here we give them a big pile of cards that look like this. And we say these cards have been left in a real mess. Can you help us tidy them up? And we ask the children to start by putting together some cards that they think go together because they are the same. Not all of them at that age range can do that. Some of them will create, as in the bottom example there, 2 pairs that go together rather than 4 that go together because they're the same. Some of them will just put, as in the top left one there, 3 animals that they like, they're their favourites, and find it difficult to explain how these go together and why they are similar. And eventually, this is what they will end up with through a very kind of structured problem-solving process. I'm going to show you a little video clip now of how they get from this stage to this stage, just to give you a little idea of what that looks like. Hang on 1 second. So hopefully you can see this video. Give me a little wave if you can. Okay, can you see it, Alex? Can you wave to me if you can see it? Yeah, thank you. Right, I'm going to play this at fast speed without the sound so that you can see how the grid gets constructed with the teacher's support. So here we can see the teacher explaining that they need to put the cards together in such a way that all the animals are together and all the colours are together. And you see one child beginning this process. He started with the orange cards. And now he's adding the blue cards. So the teacher's asking the children to explain what he's done. Why has he done that? Here he comes, he's explaining it. And the other children now begin to understand and they begin to join in. So you can see at the moment they've got the colours together, but they haven't necessarily got the animals together. And the teacher's asking them to check that. They found the 2 cats are together. Oh, there's 2 ducks together. Let's see if they can now begin to adjust it to get all the animals together. And there you see the grid beginning now. So you can see now that even after that explanation of how to keep the animals together, the next person that adds a colour line is not necessarily putting them in the right place. So the children all need to check that for her. Okay, hopefully that gives you a little bit of a flavour of how the lessons work. And I know that won't be helping you with your problem because that was a small group activity. I'm just going to show you another kind of tip that might help you with this, and this one is especially for you, Alexandra. This one will be particularly relevant for you, actually. Okay, so this one, number 2, is about high quality maths talk. So the Let's Think Maths approach is very, very rooted in talk, in dialogic teaching, in oracy, or what's also called social construction. And sorry, just let me try and go ahead. The way we think about this is moving away from show and tell to something that the Japanese teachers call neriage. And this is a really nice model that exemplifies this. So I guess the problem for your students, Alexandra, one of the problems is, why would I bother listening to other people's ideas in a mathematics lesson? And if we can build that idea, that culture, that we can only solve this mathematical problem if we all listen to each other's ideas and we all collaborate with each other, that will help us to solve this mathematical problem. So in all of the Let's Think lessons, the children work in small groups to try and come up collaboratively with some solutions to a mathematical problem. So they might be in 2s or 3s or 6s, depending on the age of the students. So when the problem is set, as in the first bubble there, you can see lots of different solutions will come out because everybody's working in different collaborative groups. And what normally happens in what we might call a show and tell classroom is that the teacher would ask each group in turn to come up to the front and show what they have done. The problem with that is that there's no reason for other students to hear that. That's not the solution I did. So they'll wait to show their solution and then they will sit back down and not really listen to anyone else's. What we do in show and tell is something that the Japanese have called neriage, which is basket work or weaving. And how that works is that the solutions are compared and discussed instead of just being shown and explained. So the first group of children might come up and explain their solution, and other children will then be asked, what do they think of that solution? Do they like that solution? Is there anything they would change about that solution? If it's an unfinished solution, how would they finish it? Then they can have a little vote on what they think about that solution and give their views. And so we proceed. We may not look at everybody's solution because it will be for the teacher to decide which solutions are important to look at. But it means that there's a reason for listening to others whilst they explain their solutions. Okay, next one, Alexandra. This will hopefully be useful for you as well. This is about metacognition. Metacognition at its heart is thinking about your thinking, and metacognition happens throughout Let's Think lessons. We know that metacognition is really, really powerful. Here's a little bit of evidence to show that. If you teach in a classroom where metacognition is really embedded, you can add an extra 7 months of learning in any calendar year. So very easy to implement and adds a lot of value to learning. You might have heard of John Hattie, his big hitters. So these are his kind of top, how many have we got here? Top 8, I think. Oops. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, top 10. And metacognition comes in at number 5. So a very, very powerful way to improve learning. And this kind of helps with the process, Alexandra, that I was talking about earlier, about how you manage those show and tell kind of episodes and move them into neriagi. So there's a couple of tips here that might help you. So when the children are doing their problem solving in their groups, the teacher does another Japanese word here. I'm a big fan of Japanese mathematics teaching. The teacher does this process called kikanshidu. So while the children are solving the problem, the teacher walks around the room and watches and sees how all the children are solving the problem. So they're working independently, and the teacher's just watching to see how are they solving this problem. She's also deciding which solutions are interesting and in which order she would like to look at them. And this is very important in mathematics teaching. So it's always a good idea to start with partial or incorrect solutions and work your way towards more successful solutions. People will not want to share a solution that's partial, incomplete, or has a misconception in it once they've seen a perfect, amazing solution to a problem. So that's really important. And the next rule that we have in Let's Think is don't ever evaluate the solutions yourself. So this involves a real change in terms of the way you speak to students in mathematics lessons. If you are never the person who tells the students whether a solution is right or wrong, then that means you have to change your language in lessons. So instead of saying good, yes, well done, correct, you say, interesting. What do other people think about that? That doesn't give away whether it's right or wrong. It encourages children who have done partial solutions to carry on explaining what they've done. And it makes them much more likely to value misconceptions as kind of thinking tools in lessons. It also really encourages your lower achievers in lessons to be willing to come to the front and share their ideas, because even mistakes can be interesting and they're worth exploring and talking about. And then instead of you being the person who decides whether these solutions are good or not, it's for the class to decide that. So, okay, we've looked at 3 or 4 solutions, we've reflected on them, we've heard people's thinking and why they did it that way. Now we're going to discuss them, evaluate or vote on them and decide which ones we like best and why. So those metacognitive episodes happen throughout a Let's Think lesson. And I'm going to just show you quickly an example of that in a short video clip.
If I was measuring with my if I was measuring this table and I wanted to know how long it is, what's the most accurate way of doing it with what we have? What's your idea?
I think the most accurate thing to do is to use the pixie feet.
So you would just use the pixie feet for this table? Okay, hands up.
Let me give you a little bit of context for this before we start. So they've been given a large foot, which is called a giant's foot, and a small foot, which is called a pixie foot. And each of the pixie feet is 1/10 of the size of a giant's foot. So it's basically decimal in terms of measurement. And they've been asked to go around the classroom and measure some objects. And the teachers noticed some very strange ways in which they're using the giant's feet and the pixie feet to measure.
You disagree with her? Why?
We can use 5 pixie feet to measure the table.
You could use 5 pixie feet to measure the table. 5 of these. 1, 2, 3, 4, 5. What do you mean?
5, like 1, 2.
5 strips of these. Okay. Do you agree? So we just use the pixie feet to measure something big. Hands up if you agree with that.
I'll use the giant feet because the table's quite long, and if we use the pixie feet, it can take kind of long to do it.
Do you think using the pixie feet for something big will take too long?
So, because the giant feet is much more bigger, I think it would be much more easier.
You think it'll be easier because the giant's foot's bigger? Okay.
Measure the board.
So you'd measure the whole board just with the giant's feet? Hands up if you've got a different idea.
I would use both.
Show us what you mean. You can sit down.
This here, then put my hand there, then I'll put that there, and I'll keep my mark. And just because I can't fit the rest on, I could use that, and then I can mark where it stops.
Ah, okay, you would mark where it stops using the pixie feet. Hands up if you think this is a better idea, to use the giant's feet and the pixie's feet for big things. Hands up if you think it's better to just use the pixie feet. Right, so it looks like more people think that Yasmina's idea and your idea is better. So if you continue using the giant's feet and the pixie's feet to measure big things, make sure you record what you find out, so carry on.
So hopefully that gave you a little kind of insight into a metacognitive episode where the teacher spotted a misconception and brought it to the group. Alexandra, I don't know if any of those ideas kind of help you with your idea of concentration beyond small groups.
The difficulty for me is to make them to begin an activity. You know, they need a lot of help if they are very full, if the class is full. And when I work with a few groups, it's better, because when they are in larger groups, I had to spend a lot of time with them to help them to start and to continue.
A lot of the, a lot for us in the Let's Think lessons, a lot of getting them motivated to start is about the context for the mathematics. So if they think they're just learning a piece of mathematics and they're going to be taught a piece of mathematics, it's not very exciting. We often tell little stories to start the lesson. So for the largest rectangle, for example, we usually say that this is a problem that another class gave us. They were arguing over which was the largest rectangle, and I wondered if you could help me by working that out. For the farm animals, we say these cards were all in a little mess, and I wondered if you could help me to sort them out. There are other stories where we tell them about other real life examples. So there's one, for example, which moves into algebra, where we talk about playing in a sports league and playing home and away and trying to work out how many matches there will be. So part of that for us getting them started is about having the right, what we call hook or context for the learning to get them hooked in. And then the other bit about getting them to continue to work is about their engagement throughout the lesson by keeping them involved and motivated and wanting to solve the problem, even if the mathematics gets a little bit tricky. And we find that if they believe in the problem they're trying to solve, they're much more likely to maintain their enthusiasm throughout the lesson. So yeah, that's kind of my best advice about that, Alex. Is there anything else in particular that you can give us details on?
No, I agree with you. It's easier with the youngest, but with older teenager, it's more difficult because it's more abstract. It's difficult to find sometimes concrete things to explain.
Yeah, I think you'll find that in every single mathematics lesson, it's always set in a concrete context. There are 5 principles of the approach. The first one is concrete preparation, which is that the problem must be set within a concrete context that engages and motivates students and which they can understand and use to solve the problem. So it has to be set in a context that's meaningful and relevant for them in order to solve the problem. The next one is cognitive conflict. And that means it's got to be just the right level of challenge, not so easy as the problem can be solved easily, but not so difficult as it's out of their grasp in terms of what we call the zone of proximal development, according to Vygotsky. So we make sure that the lessons will work for a really wide range of achievement, because we know that teachers are teaching in classes where students are really struggling and really excellent at maths, often at the same time. Mm-hmm. Then we have the social construction, which again is a tool to kind of keep students engaged with the problem. All of the lessons are talk-based. They're always collaborating with their friends and their partners to solve the problem. And we find that that keeps them motivated as well. And then also the metacognition, the metacognitive episodes that I've described, keep pulling them back into the thinking and saying, what do you think? Everyone has to have a vote. Let me know what you think. And these are all tools deliberately designed to keep them motivated and engaged. Mm-hmm. And those are the things that when I did my original Let's Think training, it really made me think about my own mathematics teaching. How often do I make my maths teaching real and meaningful and authentic for them? Or am I just saying, today we're going to do column method addition, for example? Is that real, meaningful and authentic for them? Why do they need to know that? And also making them more talk-based and collaborative, so that students who are struggling don't feel alone and isolated, and they can talk to each other and help each other. So hopefully that helps a little bit, Alexandra.
Yeah, I hope so. Yeah.
Shall I go on? I'll just go on to talk a little bit about the program and what it will look like. Excuse my croaky throat. Let me just have a little drink. So just a little bit about the program. Do hope you'd be wanting to come along. And these are some of the sorts of questions that we've had from teachers about this approach and their concerns about it. So I'm just raising these to talk to you about the sorts of concerns that other teachers have raised. So the first one up there is one I just spoke about, which is, how do I evidence learning if it's all talk-based and collaborative? That's been one of the questions that teachers have asked us. So what's interesting about the Let's Think Maths lesson is you're only teaching them once a fortnight. So you'll still have lots of evidence in your books of students learning as they go through their day-to-day maths lessons. All of the impact evidence that I showed you earlier is based on them doing one lesson a fortnight. What people have done to evidence learning is 3 different things. They either take all the bits of paper in from a lesson, because they do them all on big bits of paper with big marker pens, and they put all that evidence into a folder and say, this is the lesson. Or they do a kind of scrapbook approach where they look at the top, the middle and the bottom of their class, and they collect some examples of evidence and put some names next to each of those levels. And we support you to do that within the Let's Think materials, because we have Piagetian sort of overviews of progress within the lessons. This is a Piagetian program. So we map what low achievers, middle achievers and high achievers would look like in each of the lessons. And some teachers just take that map, that grid, and write the names of the students next to each one to evidence what they've done in that lesson. So that's one thing. Then Alexandra, probably that one is quite relevant to you. My students don't collaborate or listen to each other very well, possibly. Yeah, we see introducing the Let's Think approach as a way to deal with that problem. So the Let's Think approach trains students to collaborate and listen to each other, and we offer a lot of advice on how to do that. So this can really change the social atmosphere inside your classroom and make it easier to do your day-to-day teaching. We actually do a lot of our metacognition in the lessons about the extent to which they have collaborated or listened to each other. So we ask them to reflect on how they're behaving in the lessons and whether that could be improved. And when they do this lesson again, how are they going to improve it? And then the last one, how will I fit it in? So again, you're using one lesson a fortnight for your mathematics. And what it's really enabling you to do is to assess whether what you have taught them has been learnt. So it's taking because what they have to do is pull the learning out of your daily maths lessons and apply it into this problem-solving context. So it's a really great opportunity for you to assess what they have learned and decide what to teach next. And I talked to you before about it being really transformative. Oh, just a little bit of information about what you get. We give you real lesson examples. We give you very detailed lesson plans, and we look at a lot of live clips of lessons. We offer you videos for interactive professional development with your team. So we strongly suggest that you do these lessons with other colleagues. You test them out with other colleagues because we think that's a really great way to practice them. We give you some theory input and some practical ideas for pedagogy in the classroom, just like the ones I've given you today. And we give you also some ongoing advice and support to help you map Let's Think into your curriculum. So where should the lessons go? When should I teach them? And so on and so forth. And here briefly is just a couple of examples of the sorts of things that that teachers who've been on the programme say about Let's Think. So I'll read those out briefly for you. So the classroom practice was the best thing as it has enabled children to shine that wouldn't necessarily during normal curriculum activity. It also gave me a better idea as to their true abilities and potential. Yeah, this is quite an interesting quote actually. Teachers that teach Let's Think often say that some of the children that they thought were really weak at mathematics actually really shone in these lessons and really could solve these problems. And I have often wondered why that is the case, because I've noticed that as well. And I think it's because if you're a lower achiever in mathematics, you have to be creative in how you solve problems because you don't necessarily have the number skills that other students have. And so this is a real confidence boost for low achieving students. And it's really great to see that happen in maths lessons. Having the chance to explore the materials as a group meant we could see what the children would experience in the lessons and could discuss this with others. Team teaching makes the sessions even more supportive. Yeah, we talk a lot about the lessons. We go through them in quite a lot of detail, and we try to do a lot of anticipation of how students will respond to these lessons. And we know from research that your ability to anticipate student misconceptions definitely improves your mathematics teaching. So we do spend quite a lot of time unpicking that and exploring that with a group of teachers on the programme. So that's the sign-up link for the programme. Are there any other questions or things that people wanted to ask or say or get advice on?
It's okay now.
I hope it's been helpful.
Yeah.
And I really hope you join the programme. Yeah, it would be lovely to see you there.
I'm using your QR code.
Oh yes, please do. Be lovely to see you on the course. Have you got it, Alexandra?
Yeah.
And if you have any other questions between then and now, there's my email address. Please feel free to contact me.
Okay.
Yeah.
I take a picture.
Have a great Christmas when it comes.
Thank you. You too.
All
Thank
right.
you.
Bye-bye.
Bye.
See you soon.